Thank you, sir, for such a nice introduction. First of all, I would like to thank the organizing committee of this event for giving me this opportunity to interact with the students and faculty members. And this is also a very good opportunity to visit such a reputed institute and discuss the things that I am carrying out in my research and about some topic like FTIR or instrumentation. So I would like to start with my topic is identification of illicit drugs using FTIR. FTIR as this workshop is based on basics of instrumentation, many type of instrumental technique. So I would like to say that this is most relevant topic in related to forensic science. As we can see, forensic science is basically, as you might heard in recent years, there is a lot of concern about the forensic science, and you listen so many news related to forensic science, and in case of any crime, forensic science people are there, and a serial CID you are seeing so many years where Dr. Salunke is there, he is doing some experiment related with forensic science. So basically forensic science is mixture of all the basic sciences, whether it is zoology, botany, chemistry, physics, math, accounting, commerce, everything will be there. The thing is that once we use that technology, basic science technology for the purpose of justice, then it is known forensic science. But itself independent forensic science is not a different science. It comes from the basic science only. So that's why there is instrumentation technique, there is chemistry is also involved, physics is also involved, zoology, botany is also involved, like DNA profiling की बात करेंगे. So these all things will be there. So forensic science is knowledge and application of all the scientific method and technology also, like engineering field also, for the purpose of justice. So if anybody is doing MSc chemistry, so that is in MSc chemistry there are so many instrumentations. So likewise, every instrumentation will apply in forensic science. So we are dealing with all kind of instrumentation because we have to analyze the evidence that we got from the crime scene. So from the crime scene, we could get any type of evidence. That could be a protein sample, that could be a polymer sample, that could be a hair sample, that could be biological fluid, that could be soil, petroleum product, cosmetic product, any type of material may be there. So we need mostly all type of instrumentation in our laboratory. But that laboratory will be divided into different sections: physics, chemistry, biology, document, cyber, like that. So it is a kind of applied science that is basically applied for the society, for the benefits of society, and for the purpose of justice. And in India, it is known as forensic science, while in US it is known as criminalistic. So we can see here, in the forensic science is application of science and technology for the purpose of justice. In recent years, there are many emerging areas of forensic science, as you are students of different disciplines. So in future, if you want to pursue your career in the area of forensic science, because as I am coming from National Forensic Sciences University, it has around 8 campuses all over the India, and 5 new campuses will start from the July onwards. So there are 13 campuses, and that is also an institute of national importance like manit. So that will be opportunity for the students all over the world, because there are so many international students are also there in our university. So emerging area, if we can see, there is DNA profiling, drone forensic, metabolomics and proteomics, if we could go in biotechnology or biochemistry. Cyber forensic is also there, AI is also there, humanitarian forensic is also, and how we have to behave with the dead body. That is comes under humanitarian forensic. Like if you are aware about the postmortem, like people who, if death is occurred, postmortem will be there, but the reputation or of postmortem and the doctors who are doing that, that is not very good, and you all know very well. But in AIMS, Bhopal, and some other reputed institute, and people in some other medical colleges, those are reputed medical colleges, they are doing very good work in that area. So they behave in a very good manner with the dead body also. That will come under the humanitarian forensic. Next is forensic nanotechnology. Then again it is under the chemistry or physics, how to prepare nanoparticles and how those nanoparticles will be applied in the area of forensic science. Like we could prepare nanoparticles through which we can develop the fingerprints. So if there is a crime occur and any criminal touch any surfaces at the area of crime scene, so how can we develop that fingerprint? So there will be a fingerprint powder. And if that is a nano-based fingerprint powder, nanotechnology-based nano formulation, so result will be very good. And then isotope detection. Isotope detection, there is a IRMS technology recently procured in our Gandhinagar campus. So on the basis of this isotope detection, we can find out the origin of that particular substance. Like in smuggling, there is a situation when we have to find out this particular afim or heroin sample or cannabis sample, what is the origin, from where or from which country or from which location it started, and then what is the where it is smuggled. So that type of detection can be carried out. So database is ongoing. People are preparing database because database is not available right now. And then lie detector, brain imaging, and narco analysis. This is very fascinating in the area of forensic science. Lie detector, as you all might know, that if you will tell a lie, then there will be a machine that will tell you that whether you are telling a lie or not. Basically, that is based on the psychosomatic action. Whatever the biochemical changes occur in our body, that will find out. And then forensic neuroscience. This area in which we are working in forensic neuroscience to find out the pro-criminalistic approach. Like before committing a crime or before committing a crime, can we find out that this particular person is prone to cause any type of murder, or that person will commit suicide, or that person will show aggressive behavior. So that kind of thing we can find out so that we can prevent a particular crime. So if we talk about the illicit drug, because this is an application-based science, so we discuss about the FTIR instrumentation. But that instrumentation, what will be the application? What type of substances we can detect? So here we have illicit drug, that is also we can say illicit drug or illegal drug. Or we can also say like narcotics, NDPS, controlled substances. The drug which is controlled, their use is controlled. Like diazepam, that is given sometimes if a person is not feeling well, insomnia is there, sleeping problem is there, then diazepam will be given by the doctor. But diazepam we cannot store because that is a controlled drug. Likewise, morphine is there. If there is a severe pain or spinal cord injury and there is an operation carried out by a doctor, then they will give morphine, generally in military hospital. But morphine, they people started to use as a drug of abuse. The person who are using that morphine, they are using that as a drug of abuse. So people started to make some designer drugs also. So designer drug will have the effect like morphine, but that is not basically morphine. So illicit drug, you can say, it is a substance that is illegal to possess, produce or distribute, often with a high potential for abuse and harm. So this abuse is basically depend on the psychological and physical dependency. Any type of drug that is causing psychological or physical dependency, that will come under the category of drug of abuse. So can anybody tell me the difference between, because that is not related with your topic, but that is related with your lifestyle, psychological and physiological dependency. Can anyone have any idea about that? Okay, so psychological dependency, where there is a craving effect. Like सुबह चाय हम लोगों को चाहिए ना, that is a kind of psychological dependency. चाय नहीं मिलेगी, so we can't do some work. चाय और coffee. Or sometimes people use nicotine, तंबाकू खाते हैं कोई इस तरीके का, so that is required. Sometimes जो तलब लगती है इसको craving. But if you will not consume that, there will not be any physiological effect. There will not be tremor effect. You will walk properly, you will think properly, everything will be normal. But you you want that particular tea or coffee. That is psychological dependency. And if there is an effect, like if that thing you will not get, there will be sweating, there will be tremor, you will not be able to work. That is physiological or physical dependency. So that is the difference between psychological and physical dependency, and these drugs work on that only, and on the basis of that, these drugs are categorized in different schedules depending on the Controlled Substance Act, that is world level classification. Illegal production, trafficking, distribution of drugs, major global concern. Illicit drug use carries significant health risks, including addiction, overdose, long-term health effects. These many drugs cause neuropsychiatric health problems. Sometimes the drug that is used for the treatment of neuropsychiatric disease, those drugs also found to cause neuropsychiatric diseases. Initially, we started to take drug to treat that particular disease, but after that, that drug is causing that disease condition. Like depression के लिए दवा start किया था ना, but that drug is started to cause depression. So that kind of health effects will be there. Then some of the substances like alcohol, tobacco are legal for adults in many places. Their use is regulated. There is some limitation, some quantity that you can take during the visit or during the when you are moving close to. Okay. So next, there is a drug classification. If we talk about the classification of drugs, there are mainly 4 categories like narcotics, depressant, stimulants, and hallucinogens. So these 4 categories drug, based on this, they have been categorized into the drug of abuse, into the NDPS substances, narcotic and psychotropic drug substances also. So all drugs, legal or illegal, are classified into different categories. So this classification is basically used in the forensic science, and other than that, pharmaceutical science has another classification in which you will find antibiotic, antiviral. Okay. So there are some antipyretic drugs, analgesic drugs. So that is not very much used in forensic science, but these drugs classification used in forensic science because mainly crime occur due to the use of these drugs. So in case of narcotics is term is coming from the numbness, means sleep-inducing drug. The drug, by consuming it, it will cause sleeping effect, when you will feel drowsiness. So this narcotics and depressant both will be the same category, but based on the origin of substance, somewhere it is said to be narcotics and depressant in 2 different categories, but other places you can find it is single category. So in this opium alkaloid is there. Opium means afim. Afim, there is a plant, Papaver somniferum, or khaskhas, everyone knows. Khaskhas is the seed of that opium, afim. So in that khaskhas, there is no morphine or no opium alkaloid, or there is a very less amount of that. So that is, we can consume that, there is no problem in that. So opium alkaloids contains morphine, and once the morphine is reacted with acetic anhydride, it forms heroin, and that is a very potent drug of abuse. So heroin, we all know that once it is reacted with acetic anhydride, and there will be a diacetyl morphine, that is also known as heroin. But the important thing with the heroin is that once anyone consumes this and death occurs, then heroin will not be found in the body because it will convert it into morphine, diacetyl morphine. So there are so many cases once it is reported that that person consumed heroin, but it will not be detected in the blood, urine, or any biological fluid or viscera. So diacetyl morphine will be detected. So likewise, depressant, barbiturate, and tranquilizers. So like diazepam is there, barbiturate is there. So any person is not having sleep properly. People are feeling anxiety so many times. So neuropsychiatric doctors prescribe these depressant drug. And then stimulants, the people become feeling high in case of stimulant. They say you saw a movie in which Salman Khan wants kick. So that kick means there is a stimulant drug is required so that person feel high. So that is from the tea, from the coffee, from the amphetamine, from the cocaine. You will find out this kind of, and this amphetamine is divided into two more categories, that is methamphetamine and methylene diamine methamphetamine, that is ecstasy. That is very common in teenagers. And these are known as club drugs. Person consume it and then they will do party full night because they will not feel tired. So that's why it is called club drugs. Teenagers will consume it and they will feel high and energy will be very high and they can dance a full night. There will not be any tiredness. So this amphetamine is so many times reported in forensic science in the blood and urine sample. And this depressant category drug, there is a category benzodiazepine that is not written here. That category is in that category there is a drug that is called date rape drug. That is also very common. Rohyphenol is the name of drug, but any drug that is used for that purpose that will come under the category of date rape drug. So I am giving you the background of this because these all drugs we are detecting using the FTIR, using the other instrumentation also. So these date rape drug is generally used to commit the crime, and if the person, one person has given date rape drug to any female person, then that drug can be extracted from the blood and urine sample and detected, and we can find out, yes, someone has given this particular drug to commit such a crime. So that will come under the depressant category drug. And then last is hallucinogens. Hallucinogens में जो category है that is LSD, lysergic acid diethylamine, and that fungus is there, that is but fungus is there in wheat, so that is extracted from that particular fungus. Okay, so that is a highly potent hallucinogen. Even 1 mg concentration can cause hallucinogenic effect. Now, can anybody tell hallucinogen or hallucinogenic effect?
सर भ्रम, सर इन हिंदी भ्रम,
भ्रम, और कुछ और एलाबोरेट करो उसको.
सर दो देखना 3.
That is basically इसको और अगर हम हिंदी में बोले, गांजा भांग या चरस खाने से क्या होता है, that is hallucinogen. अब गांजा भांग या चरस खाने से लॉस ऑफ स्पीच तो होगा नहीं, सेंसेस काम करना बंद नहीं करेंगे. So what will be that? Hallucinogen. Because इसके भी केसेस आते हैं. There is an interesting finding with this. If a person consumed ganja, bhang or charas, generally bhang is available, that is legal, with people can get license and that they can easily sell in the market. But in case of bhang and charas, that is illegal. So the quantity is defined. So people are consuming bhang is also illegally people are getting. Charas is limitations. Charas easily people are not getting, and that has intensity, various intensity of that. So hallucinogens जो हैं, चरस, गांजा, भांग या LSD, आप लोगों ने एक सीरियल सुना हो चंद्रकांता, हम लोगों के टाइम पे था, आप लोगों के टाइम पे भी, जो देवकी नंदन खत्री है, कहा जाता है he wrote that serial once he consumed cannabis and then he wrote that serial. हैरी पॉटर आपने सुना है, that is all imagination. So that imagination will come once people will be influenced in this kind of drug. That is a kind of bhram. Bhram means what? The thing that is not existed. So hallucinogens में क्या होगा? False sense of perception. False sense of perception when external stimulus is not present. Means रस्सी को सांप समझना, that is not hallucinogen. Because रस्सी is there. When रस्सी is not there, and if you are thinking yes there is some snake, that is hallucination. Means false sense of your all the senses, 5 senses will perceive false information. You are feeling something sweet or sour in your mouth and nothing is there. You are feeling कुछ मीठा मीठा लग रहा है. You are feeling some song is there. Other person are not feeling, but there is no song. If you are feeling something is insect is moving on your body, that is tactile. That is tactile hallucination. Means there is nothing, but you are feeling like that. And these auditory, visual, gustatory, so these five senses related with hallucination. And if Rassi is there and you are seeing it as a snake, or dog is there, you are seeing it as a lion, that is illusion. Magician doing that. Magician will show you one thing and your interpretation will be different. So illusion will be false interpretation of senses. Hallucination is false sense of perception. Okay. So these drugs will, if anyone consume, then it will cause hallucination. And the most important thing in case of ganja, bhang and charas, if anyone consume that thing and other person will tell that person that another person is coming to kill you, that person will go and kill that person, and after that that person will either commit suicide or surrender himself or herself. That is called run amok, a condition. You start to run and kill that person. Just by anyone come and say that person is coming and that person will kill you. But that case may not be there because इसको मारने जा रहा है, that person might be more powerful, वो नहीं मार पाए, but the situation will be like that. So that kind of cases will be there. People who are committed any crime, they try that they are not mentally fit or they are mentally ill, so that they will not get the proper sentence of death or lifetime imprisonment. So these illicit drugs people are using for that purpose, or lawyers are using these conditions for that purpose. So these kind of cases we receive in forensic science laboratory and examine these cases by using different instrumentation technology. So there are many other cases, but as per the time constraint, we discussed only about the illicit drugs. So commonly abused drug, if we say those are benzodiazepines, जो अभी डेट ट्रिप ड्रग बताया मैंने, डाइजिपाम है, लर्जिपाम है, क्लोनाजिपाम है, these all drugs will be there. Then amphetamine, methadone, ये methaqualins में Mandrax. In news you can see so many times in Bhopal only, there are so many times Mandrax is seized. Mandrax drug is smuggling हो रहा है यहाँ पे, so many crores of rupee drugs has been seized. And then codeine, glycodine syrup, everyone knows about glycodine syrup. So that codeine is there. So now it is banned, but is still available by some other name, or people cannot store that particular codeine. That is cough syrup पीने के बाद में नींद आती है ना, that is just because of codeine. That is opium alkaloid. ये अफीम का एक derivative है. So that's why people are feeling sleepiness. Then morphine, that is the same. Heroin, that is also known as brown sugar prepared from morphine. Cannabis, ganja, bhang, charas, hashish. Hashish is oil. That is from the ganja, bhang, charas जो plant है, cannabis sativa, you will get the hashish oil. And mazoon is the sweet prepared with the help of that particular ganja, bhang, charas. होली में जो गुजिया है, if you will make cannabis in that will be known as mazoon. If sweet, lassi will not come in that category because that is a liquid. Solid sweet comes mixed with the cannabis, that will come under the category of mazoon. And if anyone consumes and if there is any problem, that sweet sample will come to the laboratory and we have to find out whether there is a ganja, bhang or charas and what is the quantity of that particular substance. Then alcohol and then thinner. Thinner is also, some people start to smell that thinner and they used to abuse that particular thing. Then toxicological evidence is what we found in our laboratory, that is alcoholic drink, poison substances, viscera, anyone knows? Viscera, internal body organ. Once the death will occur, then liver, heart, kidney, and intestine, these all will be cut into small piece, like depending on the quantity, half kg or 250 gram or 100 gram, that will be sent to the laboratory. So we have to extract the poison or drug from that viscera and then we have to examine. Then stomach was, like either person vomit will be there, or if death will occur, then stomach mein whatever is available, that will be sent to the laboratory. Then hair sample, metallic poison, plant poison, animal poison, toxic gases, and any other metrics also. Drug related evidence we can see, drug in food, viscera, stomach wise, almost same cases, but there will be some different drug categories also there. Okay. Isolation of poison, because once you are this workshop is related with the instrumentation, but unless you know the extraction procedure, and if you do not know the basic sample preparation, you cannot use any kind of instrumentation, either FTIR, chromatography, spectroscopy, chromatography, any kind of higher instrumentation you can never be used without the preparation of sample. So sample preparation is very much required, and in the sample preparation, the step is extraction of poison or drug or substance from the matrix. Matrix is basically the substance in which your analyte of interest is embedded. Like if there is a viscera, then poison will be in the viscera. If stomach gas, poison will be in the stomach gas. If cold drink, then cold drink will be in the cold drink sample. So cold drink will be matrix, hair will be matrix, tissue paper will be matrix, even soil will be matrix, even blood will be matrix, anything in which the analyte is present. And first you have to extract the analyte and then you will go for the instrumentation. Without that, you can't go for the instrumentation. Like even in FTIR also, you cannot take the blood and analyze what is available in the blood. First, you have to extract the poison or substance of interest, then only you can do the FTIR or chromatography. So there is viscera, matrix, there are some distillation, digestion and extraction techniques. We will not go in the details of that, and these are the types of poison that we usually find out. And if we talk about the analytical instrumentation technique that you go through the various lectures related with chromatography or spectroscopy, we will focus on infrared spectroscopy, like UV and other people have already discussed, and we will discuss in the next 1 or 2 days. So spectroscopy, you might have a lecture related with spectroscopy, and you all know about the spectroscopy, that is the interaction of radiation with matter. So there will be many types of interactions will be there. So based on that interaction, we can categorize the type of spectroscopy. So basics of spectroscopy, we can say, if matter is exposed to electromagnetic radiation, and these electromagnetic radiations are available everywhere. We are surrounded by so many electromagnetic radiation. Right now we are surrounded by radio waves, microwaves, infrared, UV rays, visible rays. So many radiations are there. Some radiations we can find out easily, we can see with the help of some device, and some we need some very advanced instrumentation or devices. So with the help of that, we can find out how those radiation interact with the matter. That will define the type of spectroscope. Like infrared light, the radiation can be absorbed, transmitted, reflected, scattered, or undergo photoluminescence. Basic of spectroscopy is that substance have an absorption spectrum. Atomic and molecular constitution determine about the substance absorption pattern. And energy difference in the two energy states of the molecule determine the frequency of light radiation absorbed by a particular substance. So like UV visible spectroscopy, that is an absorption based spectroscopy. IR is also absorption based spectroscopy, but in this case, molecules will not be excited because IR is not sufficient to get excited the atom, and atom will go into the higher energy state. Likewise in UV visible spectroscopy. And in this case, what will happen, that we will discuss basics of chromatography, that once the radiation interact with the matter, there will be photoluminescence, transmission, scattering, absorption or reflection. So based on these, there are different kinds of spectroscopic technique. Those are based like radio waves ke basis pe, there is a spectroscopic technique. Can anybody tell which spectroscopic technique is based on the radio waves? NMR. What is the other name of NMR, you know? MRI. So MRI is also NMR. But जब भी हॉस्पिटल में जाते हैं, people will not write NMR because generally आम इंसान जो है, general public is we can say afraid about the term nuclear. So nuclear देखेंगे तो डर जाएंगे. So that's why they are not writing it NMR. They are writing it MRI. magnetic resonance imaging. Okay. So based on that, there is a microwave, infrared, IR spectroscopy, UV visible, XRD, gamma rays पे based
Gamma rays पे based.
and other neutron activation analysis NAA. We are usually carried out analysis of gunshot residue. If there is a fire and bullet is embedded in the body, there is a pattern like bullet के साथ में there is some particles. So we can analyze those particles through the neutron activation analysis technique. So that we can find out कि कौन सी bullet लगी है, किस firearm से चली है. So those kind of cases we also receive. So Sir Frederick William Herschel, anybody knows about him? He actually, Frederick Herschel, in 1800 he discovered IR radiations. He was astronomer and musician based in Germany, and he as an astronomer, so he developed a telescope to find out the activities going on in the sky, and he discovered the Uranus also. So one time he used to find out the temperature of different lights. Like if visible or white light is there, and at that white light will be converted into Vibgyor, 7 rays, what will be the temperature of all the 7 rays? So what he did, he took 3 thermometer, that is based glass thermometer, and he used to put it in violet light and 2 thermometer nearby as a control sample. So what will be the temperature of violet and what will be the control temperature, and they find out from the control violet has higher temperature, then indigo, then blue, then likewise. Once they put it on red and then other 2 thermometers they put it nearby as a control sample, they find out that control samples have higher temperature in comparison to red. Then they find out there is some other radiation also through which this temperature is become higher. So on the basis of that, they discovered infrared radiation. And then afterwards, infrared spectroscopy developed, and they find out that technology can be utilized for various purposes. So it is a technique based on the vibrations of the atom of a molecule. It is commonly obtained by passing infrared radiation through a sample and determining what fraction of incident radiation being absorbed at a particular energy. Different functional group bend, stretch, back in at different frequency. All a functional group will absorb light if the frequency of the light matches the frequency of that vibrating molecule. So here that is a very sometimes once you will go through the YouTube or go through the literature, sometimes it is confusing. You will not be able to find out what is actually written or what actually YouTube पे जो भी person is telling. The thing is that once we talk about any molecule and there are bands like C or O, so in this case what will happen, once IR radiation will fall on a molecule, that will absorb light, but that absorption will depend, that the first thing is that the energy is not sufficient that molecule or atom will absorb the light and go to the higher energy state. That will not happen because energy is not sufficient. Sufficient energy is required to get it in the higher energy state. Then what will happen in this case, in a CO molecule, there will be a vibration occur. Between the covalent bond C and O, there is a vibration. Like these C and O, like a spring. So O and C like this. There is a vibration like this. There is a vibration like this. There is a vibration like this. So that kind of vibrations will occur. And that is always happening in every molecule. Every molecule has certain kind of vibrations. And that vibration has certain frequency also. That vibration will be of 2 types, like stretching, like this, and other will be the bending, like this, and like this. So these vibrations will occur in every molecule. So once infrared radiation will pass through this molecule and the frequency of this infrared will match with the frequency of this vibration that is already occurring in the molecule. Then that particular frequency will be absorbed. So, in some books or other literature, you will be confused that once IR will fall through any molecule, it will cause vibration. And once it causes vibration, then frequency at which it vibrates, it will be detected. That is little bit confusing. It will not cause vibration. It will absorb once matched with the vibration of at the frequency that is already going on. Only what it will do, it will change the amplitude of that particular vibration. Frequency will remain same, amplitude will higher, because this will cause vibration. But that vibration is already occurring, that is not causing. But that will increase the amplitude, so people are thinking that this is causing vibration. Understand? So this will occur only in the substance, or this will detect only the substance, those are dipole active molecule. Means electronegativity should be there. So if the dipole of, once the stretching will be there, then based on the electronegativity, dipole moment will be changed. Because stretching is there, so dipole moment will also change. So the substances, those have dipole active molecule that can only be detected through IR spectroscopy, others we cannot detect. Like carbon tetrachloride, we cannot detect. But other than that, like any other functional group, we can detect. So organic substances, those are dipole active, those are showing stretching and bending vibrations, those can be detected through IR spectroscopy. IR spectra show absorption band that enable to determine if certain functional group are present in that particular molecule. It is an easy way to identify the presence of a functional group. So this particular IR spectroscopy will tell you which functional group is present in your molecule, and based on that you will be able to find out a chemical formula, not chemical structure. So there is a limitation in IR. You will get the molecular weight, you will get the molecular formula like CH2, 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 CHO ये है. But this CHO जो है, at which C it is attached, you will not be able to find out. Like C2H5OH है, then this OH from which C this is attached, you will not be able to find out. For that purpose, you have to go with the NMR. In NMR, you will get the chemical structure, and that is very important in drug discovery, because once if you can change the molecule from this particular carbon atom to another, or you can change the orientation also, so that the efficiency of that particular drug can be increased. So in NMR that can be found out, but in this and even in mass spectroscopy, you will find out the molecular formula and molecular weight of that particular compound, and you can identify also that compound. But structure will be determined through the NMR. One can also use the unique collection of absorption band to confirm the identity of a particular pure compound, to detect the presence of specific impurities. So pure compound के साथ में if there are, like in drugs or medicines that we are consuming, if there is impurity in those medicines, that we can find out. Even the excipients we can find out. Like if you suppose you get the 500 mg paracetamol, and if you will weight that paracetamol, that will have around 700-800 mg, because that has excipients also. Paracetamol is 500 mg, but other binders will also be there. So if the binders quantity will be higher, then paracetamol quantity will be lesser. So paracetamol is a common drug, people are generally not make adulteration in that. But what about diazepam, what about any other barbiturate or some specific drugs? People will say it is 10 mg, but actually that is 8 mg or 9 mg. So that kind of purity we can check with the help of FTIR. Liquid, solution, paste, powder, film, fiber, gases and surfaces, all can be examined through FTIR, infrared spectroscopy. Earlier there was technology through which we cannot easily analyze all these things, but nowadays there is FTIR, that is called ATR technology, attenuated total reflectance, through which we can analyze these all kind of materials. I will discuss these things also. So here we can see it provides one of the best solutions for the analysis of drugs, as it has the ability to easily discriminate between drug compound as well as non-destructive technique. So this is a very important feature of infrared. The sample will remain as such. It will not be consumed. Whatever the sample you use, that sample as it is you can find. No destruction of sample will occur. Like in spectroscopy, sample will be destructed, sample will be lost. So in forensic science, we generally require a technique in which sample will remain as such. If it is mandatory, if it is not available, then we can destruct the sample. But even though we will take a small amount of sample to do the analysis, the sample will remain same. Because if the person who, if there is a in the court, and the court says that if people have not done the analysis in a better way, that sample has to be sent to other laboratory. So in this case or in that case, we have to provide the sample to them. So we can, or we have to repeat the analysis. So sample must be there. So we cannot consume all the samples. Sample we have to preserve for at least 1 or 2 years or till the case is resolved. So non-destructive sampling technique is required. So this will help that sample will not be consumed. That will remain as such. For a molecule to show infrared absorption, it must possess a specific feature, like we have already discussed, that this must be electric dipole moment of the molecule must change during the vibration, and this is the selection rule for infrared spectroscopy. There is a terminology used, selection rule, that we can say a specific feature. On the basis of that, we can say yes, this minimum criteria should be there to analyze a particular sample. So here we can see there are two types of vibrations, like stretching vibration and bending vibration. Stretching, like I say, that if it is like a spring, then stretching, it will stretch like positive and negative way. Like here you can see symmetric and asymmetric. Like this direction में जाएगा or in this direction. Symmetric or asymmetric stretching will be there. And bending, there will be wagging, twisting, scissoring and rocking. These kind of effects will be there. So if we say wagging, so this type of one will be out of plane and one will be in a plane. So molecules attached the central atom say. So that will be wagging behavior, they will show twisting behavior, scissoring behavior and rocking behavior. So these two move to each other, and then these two move towards this direction or towards this direction, like this or like this. Okay. So these kind of stretching and bending vibration will occur in specific molecules, and due to this dipole moment will change, and these particular vibrations have a certain frequency, and once we irradiated these particular chemical compound with some infrared radiation, and if that infrared radiation matched with the frequency of this vibration, that particular infrared radiation will be absorbed, and then amplitude of this will change, and it will give you a signal on your screen that will be in terms of transmittance. So vibration motion of a small part of the molecule is increased while the rest of the molecule is left unaffected. So in this case, once the infrared will pass, then amplitude of a small part of that particular functional group will be affected or will change. The diatomic molecules, such molecules have 3 degrees of translational freedom and 2 degrees of rotational freedoms. The atoms in the molecule can also move relative to the one another, that is bond length can vary, or one atom can move out of its given plane. So this is all about the stretching and bending, how it stretches or how it bends, that particular atom attached to the central atom. This is a description of stretching and bending movement that are collectively known as vibrations. So this is basically FTIR instrumentation. In FTIR instrumentation, most important thing is radiation source and interferometer. Here we can say that is IR source. IR source में you can use nichrome wire, you can use nichrome wire and Glover, tungsten filament, SGR lamp. These are the radiation sources. So that we can utilize in our infrared spectrophotometer. So this is basically interferometer is a device that consists of various mirror and beam splitter. And this beam splitter and this mirror is made up of metal coating. That is not mirror like glass mirror. That is a metal coated mirror. So those will reflect the IR radiation, generally coated with a gold palladium. So gold coated mirror will be there. So IR source once go through this interferometer, that beam will be split, and then it will move through the stationary mirror, the fixed mirror, and one will go through the moving mirror. So once this will come back, the intensity will remain same, and it moving mirror that will be changed. So there will be interference of two radiation, because here there is a path difference and here the fixed path, and this radiation once go to this fixed path and then path difference, so once they will come back there will be a interference. So this interference will be fall on a particular sample and then it will go to the detector, and this interference will allow to all the frequencies of infrared radiation. And then all the frequencies may, once it will match with the frequency of vibration, that specific frequency will be absorbed. And that vibration of molecule is unique of a particular functional group. So based on that, you can find out a specific functional group through which it is vibrating or frequency of that particular functional group. So here we can see the near, mid and far infrared and wavelength and wave number. In infrared spectroscopy, you will find that graph is inverted. It is not upright. So here I can show you the graph of infrared like this. This is inverted like this. So the reason behind this inverted graph, that once we measure the frequency of that particular substance, it is represented in the wave number instead of wavelength or frequency, because the value of frequency will be very high, or we can say 5.18 into 10 to the power minus 13. So it is not possible to write those all things in a single graph. So that's why we represent it in the form of wave number. So wave number is equal to 1 by wavelength. So on the basis of, we can easily calculate the wave number. So near infrared 0.75 to 2.5 and likewise. So wavelength will be this, and based on this wavelength we can calculate the wave number, and this wave number is utilized to prepare a particular graph, and instrument will give you a particular graph in the form of wave number, and due to this reason this will be inverted graph, so that complication will not be there. It would be in a simple format. So to maintain the simple format, it is represented in wave number. So in mid IR region, there is a functional group region and there is a fingerprint region. Have you any idea about the functional group region? Means it will tell you the functional group present. Why it is fingerprint region? Okay, or koi anybody? Why fingerprint? You know what is fingerprint? Okay. Fingerprint basically are unique structure on distal phalanges of thumb and finger that everyone knows. But this fingerprint is unique. You can even say that not even a single person in this universe has a similar fingerprint. DNA can be same in identical twins, but fingerprint will not be same. So fingerprint is a unique character. Even in clone, even in zygotic twins, monozygotic twins, in anywhere, fingerprint cannot be duplicated, cannot be matched. So that's why this fingerprint region is saying that is the uniqueness of that particular molecule. So that's why DNA fingerprinting technique, fingerprinting is, because it is comparative to fingerprint, it is similar. 99.9% it is okay in case of DNA fingerprint. But in fingerprint, you can say 100% there will no chance to duplicate or of fingerprint. So that's why it is called fingerprint region. There will no chance that two molecules have the same fingerprints. So if two molecules are different, then definitely there will be two different peaks. So that's why it is called fingerprint region, and it comes within the range of 1400 to 40. So these are radiation source we have already discussed. And in the instrumentation, like I have told you that basic sample preparation is required. Without sample preparation, we cannot analyze any of the instrument, whether it is chromatography or any kind of spectroscopy. So in IR spectroscopy, sample preparation is very tedious. But nowadays, another ATR technology is there in which sample preparation is minimized. But earlier, or even nowadays, if solid sample is there, solid, liquid, whatever, but earlier there is a technology that is called solid run in solution, and then solid film, mull technique, and pressed pellet technique. So this pressed pellet technique is a very tedious process. Solid run in solution that can easily be carried out. Solid film that can also be carried out with the help of sample holder. We can directly put the sample. There will no problem. But this sample can directly put in the IR without sample preparation. But in this pressed pellet technique, we need a sample preparation. In this technique, so in this technique, that is a very tedious process of preparing of sample for the IR spectroscopy, because in this we need a solid sample, and then we have to grind that solid sample in the powder form and then mix it with the KBR powder. And once we will mix it with the KBR powder, and then we have to press it with the help of hydraulic pump, hydraulic pressure machine, and then make it in the form of pellet. Like if we suppose we took a simple soil sample and press it very tightly, and then we will find there is a pellet-like structure. And once we will drop it, it will be destroyed. So likewise, with the help of KBR, that particular sample will be mixed with the KBR, and that will, with the help of hydraulic press, we will make it in the form of a pellet. That will be a very delicate pellet. That pellet we will put it in the sample holder, like here we can see. The grind the entire sample, weight the sample, add binder, then mix for 2 minutes, add pellet film, introduce aluminum cap, fill the mixture, press the mixture, and then perfect pellet obtained. So this particular pellet will be put into the sample holder, like in UV visible we are putting the cuvette or sample in the cuvette. In this there is a sample holder in which there is a space in which we can put that particular pellet, and then we will put in the instrument. And once the infrared radiation will pass through that, then that KBR along with the sample will, IR will detect that particular sample and give you a spectra. In that spectra, KBR spectra will also be there, but that you know that on which wave number that KBR will come, and other than that, that will be your sample. So based on that, you can easily differentiate. And then sample preparation of liquid, no preparation will be required, directly placed into cell made up of NaCl, KBR, cell protected from moisture. In FTIR, the very tedious process is that once you procure an instrument, once you will be a scientist or once you will go to visit any laboratory, moisture should not be there. Means humidity should be below 50%. Then the humidifier will always be on 24 hours. One AC will always be on for 24 hours in that IR instrument chamber. So we recently procured that, that's why I can tell you. So that moisture जो है, that will create a problem with the optics of that FTIR. Moisture should not be there. So NaCl and Kb are highly hygroscopic in nature. So with, based on this, we can never be analyze the water sample in this, or we cannot use water in that. Once if there is a hydrogen bonding OH sample is there, you will get a broad peak. So that is not required in that. Alcohol we can analyze, but water you cannot analyze. In alcohol also, methanol is restricted somewhere, but from ethanol to towards the non-polar solvent you can analyze. But moisture is very, we can say, enemy of this IR instrument. If it get the moisture, it will be destroyed. Sample, you cannot even analyze, your instrument will not be properly working, humidity should be below the 50%, and if the humidity will be more than 50%, if there is a problem, if there is rainy season, then we need to purge it with the help of liquid nitrogen every day. We need a liquid nitrogen cylinder, we have to purge it every day so that the internal optics will remain intact and that should not be affected. So in that case, this type of instrumentation and this type of precautions or care is required. And sometimes we need some hygroscopic जो pellets हैं, silica है, so that we need to put it in the instrument. There is sometimes column, those chemicals absorb the moisture. Those pellets we have to replace at every month or every 6 months like that. As per the company wise, there is some restrictions like Bruker, Thermo, or we can say Perkin-Elmer. These are the three major companies, Enten Par. These are 3-4 major companies. Those are through which you can get the FTIR instrument. Sampling of gas is also possible, but for that purpose we need a special device because there will be multiple refraction of that particular IR radiation. So this is all about the FTIR. Now a recent technology that is attenuated total reflectance. In FTIR, it is also a part of FTIR. It is an instrument. Now most of the companies, they are providing this FTIR with ATR technology. That is basically FTIR. All the process will remain there, accessories will remain there, but this extra accessory you will get. That is called ATR accessory. ATR is attenuated total reflectance, means earlier you are getting peak or graph through transmittance, but in this case you will get it as a reflectance. It is simply involving directing light through a crystal to the sample being investigated. So the sample what you want to investigate, that infrared radiation will go through that crystal sample, then reflect again to the crystal and then detector. That is the simple process. In this, sample preparation is minimized, but sample extraction is required. Like blood hair, so you have to extract from the blood and you can put it. But you need not to make it in the form of pellet. Direct liquid you can put, direct solid sample you can put, but that if it is in the pure form, that will be beneficial. If blood you want to check, you can check, but blood will have water molecule. So blood component, first you have to extract with some non-polar compound. Basically, with the help of ethanol, you can use ethanol and other. You have to extract, evaporate, reconstitute, and then you can use. Water-based substances cannot be used, so that's why you need to remove the water content through the help of a non-polar solvent or less polar solvent, likewise ethanol or other. Chloroform, hexane, acetonitrile, that any substance you can use. So water-based substance can will be you can use sometime because most of the time engineer and other person say that it should never be used. So we are also following that we should never be used the water-based sample. The light interact with the sample, passes through the crystal again and then detected. But let's dig little deeper into what is going on during this process. Crystal must have a higher refractive index than the sample so that the beam of IR light will be internally reflected and simply bounce off the sample. So if we have a IR radiation, a sample and crystal. So once it will pass through, next slide you can see. Here you can see this is a simply FTIR instrument. In this particular portion, this is elaborated view. So this particular portion you can see it's called ATR technology, and this whole device can be replaced. So this is a kind of accessory. Here you can see this particular part can be replaced. So that particular part can be replaced with the earlier technology. This is an accessory, and if you will put this accessory, this particular thing, that become ATR technology. In this ATR technology, here you can see a small area in which you have to put the sample. Means in sample will be required in mg, or you can directly put the liquid sample of this. So once you will, here you can see this is the probe. Here you can remove it, put the sample with the help of micropipette or with the help of some spatula. You put the sample and then again you add this particular probe. This probe is having ATR crystal. That ATR crystal basically diamond crystal. That diamond crystal will have higher refractive index. So once you will put that diamond crystal basically will be here in this platform, and this is supported, pointed, concave and powdered tip. This is basically tip. That diamond crystal will be at lower side. Once you will put the sample here, then IR will come, pass through the diamond crystal, then sample, then again to the diamond crystal, and then go to the detector. So the refractive index of diamond crystal will be higher. So it will bounce off. That will not transmit it. That will reflect. Once it will attach, once it will add to the diamond, it will reflect. Then it will be bounce off. Once it will bounce off, then how it will be detected? So in this case, what will happen? Like incoming IR beam, this is the sample, this is AR crystal. So once it will bounce back, then some of the radiation will penetrate in the sample, because IR or electromagnetic radiation are traveling in the form of wave and particle. So that will interact, like a straight line will not be there. There will be a wavy nature. So if straight line, that will not interact with the environment. But if it is a wavy nature, so little bit it will interact with the environment. So little bit it interact with the sample, and some of the light will be absorbed. That will be very microparticle जो sample है, microparticle samples के साथ that light will be interacted. So that microparticle samples interact with the infrared radiation, and that will give you a peak. So that peak will be detected in ATR. If light is just bouncing off the sample, how does the infrared light interact with the sample enough to create IR spectrum? That is the question. So light often, जैसे मैंने भी बताया, travel in a beam. So actually wave and wave tend to spread out a little bit in space. This means that although the light traveling through the crystal is internally reflected, but some of the light can slightly penetrate the sample. And then this light that interacts with the sample is often referred to as incandescent wave or incandescent field. Here you can see this incandescent wave. Here it is interacting with the sample. So here you can see light source, sample or ATR crystal. Sample will be placed on ATR crystal because there is a circular disc. In that circular disc, there is 2 to 3 mm. A hole will be there. In that hole, there will be a crystal. You have to put the sample on that particular crystal, and then probe you have to put on that so that it will hold the sample. Otherwise, sample may be sample sometimes if it is a liquid sample, that will not be hold on particular crystal. So there will be a probe. Likewise, ये जो probe आप देख रहे हैं, this will be a probe that is only to hold the sample. Crystal will be here on this circular disc. So this is ATR crystal, this is sample, this is IR radiation, crystal, sample, then again crystal, and then detector. So that will happen. So if we see the incident IR radiation, so in this case there is an invasive field. You can see this is, so with this sample or IR radiation है that will be interrupted, and then graph is not clearly visible, but the purpose of this presentation you will find out and you can go through that. The transmittance graph of this and ATR graph will be same. Like in earlier, once there you are not using the ATR, you are using the simple spectroscope FTIR, and you are using the ATR, both graph will remain same, but at few portion, the based on the substance, you will get the sharp peak and you will get the extra peak. So that ATR would be better as compared to transmission, but this the difference can easily be calculated or normalized with the help of software inbuilt for the analysis of FTIR. So either transmittance or reflectance, you will get the similar result because that software will normalize the result and this ATR will provide you the result without any sample preparation. So KBR pellet, NaCl, those all things will not be required. Simply you have to put the sample and click within second it will give you the graph. So this is the overview of some common crystal. Once anyone will purchase the instrument, that person have to decide at which absorption range or what type of crystal they require. So if you need hardness loop, so this range will be 45,000 to diamond crystal will have this hardness loop, refractive index, penetration depth, chemistry, physics, inertness. So based on this, the property of diamond crystal will be like this, germanium will be like this, zinc selenide will be like this. So accessible spectral range, based on this you can choose your ATR crystal because it will depend on the application of your laboratory. If your laboratory has application, because in diamond crystal these all will be there. Like in 10 centimeter it is 600, so germanium it will not give you more than 5,000 and less than 600. So based on your application, you can choose a particular type of crystal material. Generally in all the laboratory, most of the laboratory, diamond crystal is preferred because it is maintenance will not be required and they will get around 10-year warranty on this instrument automatically. So on crystal, on interferometer, on mirror, you will get around 10-year warranty. So that will not be any maintenance will not be required. Only things, precautions we have to make. So this is the working of ATR. We can see this sample radiation source will be here. Like earlier we have shown, beam splitter will be there, fixed mirror will be there, moving mirror will be there. Moving mirror means the mirror will move like this. So path length will differ. So once the path length will be, there is a difference in the path length. So the beam will be interact in interference manner. So this beam will go to the ATR crystal and then I interact with that sample and then detector and you will get the peaks in the form of graph. Now interferometer is a device in Michelson interferometer. We can see how this radiation interact through the sample, or we need all the range of infrared spectrophotometer. So all range means various hertz frequency we need, different hertz frequency we need. So this interferometer will give you all the frequency, whatever the frequency matched with the sample that will be absorbed, and these all corrections will be made through a mathematical calculation that is called Fourier transform. So this mathematical calculation within the interferometer with the help of Fourier transform give you a peak or signal. That's why it is called Fourier transform infrared spectroscopy. Fourier transform name is based on this only. So this is Michelson interferometer that we have already discussed, that sample, beam splitter, moving mirror, fixed mirror, infrared light source, that will go to the sample, and then interferogram which is generated. So this interferogram is the Fourier transform of mathematical calculation, that's why it is called FTIR, and then it will give you a spectrum. So this is the basic things about the interferometer. So now come to the detector. Detector, we will not go in the deep of the detector, but it is basically, as you know, that it will generate thermal heat. So detectors are based on the thermal heat, and some portion of IR is absorbed also. So it is based on the photodiode array method. Principle of detection relies upon the thermal effect. Sensor that measure radiation by means of the change of temperature of an absorbing material are classified as thermal detectors. They respond to any wavelength radiation that is absorbed and can be made to cover a wide range of wavelength. Numerous devices like thermal